Now let's speak about landfill construction. We will see some important elements to be considered for building a new landfill. It is usually very difficult to find a new landfill site, especially near the big cities, for different technical and political reasons. It is often impossible to find a site which meets all the environmental and economic criteria. For that reason, a lot of cities have transformed progressively their dump site in control landfill. This is the case of Rio de Janeiro, but also of Geneva, for example. Along all the criteria required for a new landfill, I will focus on a limited number of unusual ones. First, geological quality and natural protection of the underground water resources is certainly the main environmental unknown criteria. Another criteria is the site position in the service region. In terms of traffic, as we mentioned before, the base place for landfill is the center of gravity of the region. Each kilometer away from this center represents, in average, 2 more kilometers for each truck all along the river. This has an impact on the environment and on the coast. An important criteria is to have a big surface and a long-term available volume. It is important to build a landfill for 30 or 50 years. For that, it is necessary to build the first steps and to have another possibility to create future cells for the next years. Other point is to have a local availability of earthen material for the covering works, for covering the different steps of the landfill. Landfill needs a very big volume of such material to cover the waste. For that, it is eventually partially possible to use inert construction material, but also local quarries are necessary to have the required materials. These local quarries can be the next cells of the landfill. Otherwise, the transport cost will be too high to make a good job. Impermeable base layer is important to reduce the infiltration of wastewater in the ground. Many European norms are proposing plastic impermeable layers. These plastic solutions are expensive, extremely fragile in the construction and in the operation phases. Here, in an example in Albania, we can see holes made by machines during the construction or the first months of operation. To make such plastic layer needs a high technical experience and control. But why to spend so much money for this plastic technology if then this plastic layer is full of holes? I'm largely in favor of using mineral layers, using local material available locally. This needs some geotechnical knowledge in order to find in the region a good material that can be compacted with a high density and a low permeability. Normally, we need to mix different proportion of sandy material with clay and to strongly compact it in 2 or 3 layers of 20 or 30 centimeters. Here, in this example, we can see a mineral layer made by natural local material mixed with clay material. These technologies are not very far from the road construction techniques, and you definitely need a good geotechnical engineer to conduct the operation. But mineral layer will give you a very long-term, good and stable impermeable system. Remember, if we have petrol today, it's due to the impermeable quality of clay. The rainwater flowing through the waste becomes highly polluted. We call that substance the leachate. It is very important to have a very good drainage system of this leachate on the bottom of the waste. Here we have the bottom of the waste with the impervious system, and here the drainage system. This drainage system is important for two reasons. First, the leachate quantity that can flow through in the nature through the impervious layer is directly proportional of the height of the water on the top of the bottom of the landfill. If we have a good drainage, we reduce this height to a very limited level, and then we reduce infiltration in the nature. Second reason, as we mentioned before, the accumulation of water on the bottom of the landfill will increase the risk of instability, and for this reason it's very important to take this water out of the waste. The leachate has generally a high potential of clogging the drainage. To avoid that, the leachate drainage is realized through a continuous drainage layer of 20 or 30 centimeters of pervious material. It is possible to use inert construction waste for that, like bricks or concrete waste. The best is to add drainage tubes with a design allowing a future access from outside for possible control and cleaning of the main tubes. A slope of a minimum 3% to 3% must be considered. All around the landfill, a big drainage system must be constructed in order to avoid that water enter the waste. Additionally, it is also important to capture and evacuate the rainwater coming in the top of the landfill and to avoid a possible erosion effect of the cover top. The degradation of the organic matter without oxygen produces methane, as well as little proportion of other gases producing very bad odors for the human noise. Methane production has, moreover, a very high contribution to the greenhouse effect on climate. Then, the gas drainage and burning has two important functions: reduce the bad odors for the population, reduce the greenhouse effects. These are different techniques for gas drainage. As we saw, the most common are to realize stone stack during the development of the landfill. This can be done through a simple accumulation of stones or inert material in a metallic tube, which is elevated layer by layer. The accumulation of stones creates a continuous vertical drainage stack, and the metallic tubes can be used very easily to fire the gas coming from the waste. These gases represent a huge energetic potential. In the second step, the gas can be collected through a pumping system to a motor generator that will produce a continuous production of electricity. These technologies exist and are very efficient. The economic interest of this electricity production is strongly dependent on the price of the electricity. But important to mention is that such system requires a high technology as well for the gas drainage system as for the preventive maintenance of the motor. The design of the tube collecting the gas to the pumping station should be done considering a high settlement of the waste during the life of the landfill. This will create some technical problems, but can be solved. Honestly, the landfill leachate are very difficult to be treated. Usual biological process for urban wastewater have a very limited efficiency on that kind of water. On the other hand, it makes no sense to build and pay an expensive impermeable layer in plastic or mineral at the base of the landfill if the leachate are just collected and then discharged in the environment, downstream the landfill and without treatment. Depending on the climate, the best solution is often to store the drained leachate in a big basin and then to pump it and to recycle it in the waste system. This needs to have a pumping system and an infiltration system with drain that allowed the lixiviate to enter again in the waste. This storage and recirculation have many beneficial effects. First, it will treat and partially evaporate the leachate water. Secondly, it will increase the gas production and then the electric production in case of a gas-to-energy system is in place. It will generate an important volume reduction of the waste. The production of gas will reduce the organic composition of the waste, and this gain in volume will give an interesting economic value and increase the landfill life. The volume of the leachate basin has to be defined according to local climate conditions along the year. Main points of landfill construction are to use local material, implicate geotechnical engineer, control the water, capture and burn gas.